Hello students, today we're doing lesson 1.4, solving equations using addition and subtraction. Okay, this is what your book calls it, solving equations using addition and subtraction. I am going to call this lesson something else, and I want you to write this down. This is called what I call it, what we're going to be doing is one-step equations. So write that down also. Later on, we will be learning two-step equations. Okay, so I'm going to kind of teach this a little bit different than what your book teaches it. So if you don't understand mine, you can go on to the book. But I think the way that I'm going to teach it is probably a little bit easier to understand. Okay, in the past, last week, I guess, we learned with some properties, right? You learned a couple of properties, and today we're going to learn two properties also, or we're going to learn one property. So we learned some properties of addition. Today we're going to learn a property of equality, but I'm going to talk about that later after I show you a couple of things. So what I want to show you is a balance, I guess, or a scale. It usually looks like this. Sometimes when books have a balance, it's kind of like a teeter-totter, okay? So what it is if I put, okay, you don't have to draw this, but let's say I put 3 apples on this side and only 2 on this side. Then my scale is going to go like this, right? Because the 3 apples are going to make it tilt to one side, right? So that's what I mean by this is a scale or a balance. Okay, so we want to balance this equation. Okay, so on a balance, if I had 5 on this side, then I would need 5 on this side, right? I can't put more on one side or it's going to tip, and I don't want this to tip. I want it to stay the same. Okay, so when we're doing equations, we're going to have numbers on both sides of the equal sign, and we want our equation to always stay balanced. So if I add 1 to this side, then I need to add 1 to this side also to keep it balanced. Okay, if I didn't add that 1 over on the right side, then this would become unbalanced, right? Because I would have 6 and 5. So I always want to add 1. If I add 1 to one side, then I need to add 1 to the other side. In the middle of this balance would be an equal sign, right? So I always want those two sides to equal each other. So let's look at another one. If I have my balance beam here and I had 10 on this side and 10 on this side, and I take away 3 on this side, now that's 7, right? Then I have to take away 3 on this side also for it to stay balanced or stay equal. Okay, so that's what I want you to think about when you're thinking of equations, is I want you to think about keeping both sides equal to each other. Okay, and that's why when we talk about things about this property, we're going to be talking about the property of equality. So let's write down this property. This is called the addition and subtraction. Addition and subtraction property of equality. And I try to make these a little bit simple for y'all. So I don't write all the things that the book writes in this because I just want you to get the basic grasp of this, right? You'll have more difficult ways of looking at properties when you get into actual algebra. But right now, I just want to get you to understand what the property is. Remember, properties are things that are always true in math. So in the addition and subtraction property of equality, it's saying if A equals B. Okay, so think about this as a balance, right? A is the same as B. We're going to have like the balance beam, right? And they're equal to each other. So it says if those are equal, then A plus C is the same as B plus C. Okay, so they're saying that if I add C on this side, I have to add C on this side to keep it balanced. So it's exactly what I just showed you. Okay, and the same is true for subtraction. So if A equals B, and I subtract C on this side of the equation, then I have to subtract C on this side of the equation. So those are both the same. So this is what the property of equality says, is that if I'm going to have two things that are equal, then, and I add something to one side, I have to add the same thing to the other side. And if I subtract something, I have to subtract the same thing on the other side. Okay, let's look at what this means when we're actually doing a problem. So we're going to do some examples here. And I'm going to show you some stuff. The book is going to show you a different way. I want you to try it my way instead of the book's way. And I'm going to show you both ways. But the way that the book shows it, I'm going to tell you don't write that in your notes. It's okay if you do it, but I think it comes out a lot easier in your brain if you do it the way that I'm about to show you. Okay, so here's example 1, and we're going to do example 1 together. And then we're going to, I'm sorry, I don't want to do example 1 yet. Let's go back and talk about this. Okay, let's say I have the number 8, okay? How can I make that equal to 0? Well, the way I can make that equal to 0 is by subtracting 8, right? If I have, okay, hold on, I'm sorry. Let's say I have 10 plus 8, and I want to get rid of the 8, okay? Then how would I do that? I can subtract 8, and that's going to make this 0, right? Okay, so 10 plus 8 was 18, right? Let me do this again. I'm sorry. I don't have all my stuff together in my mind. Okay, 10 plus 8 equals 18. Okay, what if I wanted to get rid of this 8 here? And what I would do, is I would minus 8, right? So now that gets rid of the 8, and now I have 10 equals, and it can't be 18. I have to also subtract 8 over here. So now because I subtracted 8 on both sides, see, minus 8 and minus 8, I kept it balanced by minusing that 8, and it kept it balanced here. Okay, I hope that made sense. That might confuse some of y'all. So if it did, let's just move on. You'll catch what I'm doing in just a minute. Okay, so we're going to go on to your examples in the book. Okay, so example 1. If you didn't write down that last part and you didn't understand it, then don't worry about writing it down. Actually, the book only has a couple of examples, and I'm going to give you quite a few more, okay? We're going to do a couple more examples on this. Okay, example 1 says, solve x minus 23 equals 98. Okay, so the way we solve this is to get rid of a minus 23, we're going to do the opposite, or in math sometimes it's called the inverse. So when we do the opposite of this, we're going to undo it. So if I add 23 to this, then that will undo this, okay? And so if I add something to one side of the equation, I have to add it to the other side. So I'm going to add 23. Okay, and so the part that I circled, this part, that just goes away, right? Because if I have a 23 and a minus 23, that's going to give me 0. So this side of the equation is x, and on this side of the equation, I'm going to solve the problem, right? And I'm going to get 121. So x is equal to 121. Okay, I probably should not have used the examples in the book because that was not as friendly saying it to you for a first time doing any